Alright, friends and neighbors, welcome back to another network. It's not networking. We're going to talk about some circuits today, and in particular some chips, because we're going to be playing with a Raspberry Pi in a couple of the next videos. So without further ado, today we're going to talk about the 74LS08, or the chip with the AND gates on it. So right up there you can see the 74LS08. That is the chip that we're going to be worried about. And in our circuit today we're just going to be worrying about one AND gate. Now for those of you that are a little new to logic and or logic gates, the way that they work is they typically have a couple of inputs, and because of the way they're constructed, the output is obtained only through a particular combination of voltages on the inputs. In the case of an AND gate, we've got two inputs, one output, and the truth table below tells us what happens when we have our inputs. So if you apply a voltage, or we call that a binary 1, something happens. And if you take away the voltage, applying a binary 0, then something else happens. Okay, so we've got input 1 and input 2, or maybe A and B. If we have 0 and 0, no volts on either one, then the output is going to be 0. If we have no input on one, no voltage, binary 0 on one, and voltage or binary 1 on the other, we get a 0 on the output. So what we're trying to say here is that the AND gate has to have voltage on both. So if we do this, or if we do this, we still get a 0 on the output. The only way that we get voltage out, or a binary 1 out, is if we have voltage on both inputs, and that's what the truth table below tells us. Okay, so now that we've got our hands wrapped around what an AND gate does and how it operates, well, what's our circuit going to look like? So this is what we're going to build today. You can see that we've got a 9-volt battery that we're going to put in there, and then our chip is right in the middle. And I've gotten rid of all the other gates because we're just going to use one of them. And so we can see on this gate here, 9 and 10 are the two inputs, and then pin 8 is going to be our output. And then we run the output to an LED. So if we get the binary values that we want, the voltage that we want on the chip, we should get output from the AND gate that will light up the LED. Pretty cool. Now these other lines here, these are for powering up the chip itself. And one other idiosyncrasy of the chip is that the minute you apply power to the chip, you get power on all the other inputs. So what actually ends up happening is we take voltage away by grounding it. Sometimes you put a resistor in there. So let's get to the build. Alright, as we saw in the intro, we're going to build a small circuit, and the purpose of the circuit is to show us how an AND gate operates. So our components that we're going to use for this, we have a breadboard. We actually have a couple of different kinds of breadboards. We have a series of red jumpers. We got some black jumpers. We have a couple of test leads that we're going to use for our signal input. We have a chip. This one happens to be a 74LS08 that has a collection of AND gates on it. We have a resistor. This is a 220 ohm resistor, and then we've got a couple of LEDs, and of course our power supply. Now to get us started, I want to talk about breadboards here in general. These are two different kinds of breadboards, but essentially they're the same thing, except that this one has the power channels on the outside. And the reason it has the power channels on the outside is because this comes with the Cana kit with the Raspberry Pi in it, and what you would do is you would hook up something like this, and it would apply power down the two sides. Now, some features about a breadboard. First, there's a channel in the middle, and the whole point of the channel is to create two sides that are electrically separate from each other. So this side, and this side has nothing to do with the side below the channel. In addition, a breadboard is organized into columns and rows, and the columns are what separate components electrically. So anything put in the same, the row is what separates things electrically, and anything put in the same column would have all power or voltage applied at the same time. So if I was to connect, say, a resistor like this, the two sides would be separated. But if I connected the resistor into the same column, then voltage would be applied to both sides of the resistor at the same time, and it wouldn't really make much sense. So you have to bear that in mind when you are making your connections. Now there's also a couple of ways to apply power to a breadboard and to all the components. If I have a board like this, then I can hook up my power, to these two sides like that, and then power runs the entire length, and so does the ground. I can also, sort of spread them out a little bit. I can put the positive and the negative on the two sides and have the two sides of the circuit run down that way. Now the other way to do it is to hook up power and then hook up other things that need power to the same column. So I could hook up a series of jumpers to the same column and then apply power that way. And the same thing would be true of the ground or the negative side of the battery. Everybody could return by plugging into the same column. And I'll show both ways as we get through our circuit here. Now the first thing that we'll talk about is we'll add our chip. And so what we don't want to do is apply power to the two sides at the same time. And we don't have, another way to say that is that we don't want one side to receive power at the same time as the other one. We want to control that. So what we usually do is we put chips across our gap in the middle. Now a couple of other features of our chip, and I'll try to show you this in the camera, I can get it to flip over here, is that on one side of it there's a small dimple that's right there, and it's probably hard to see on the camera, but I'll draw a picture for you here in a second, and that helps us with where our pin numbers are. So I'm going to connect this guy in here, and you sort of want to go down, sort of straight up, and just sort of gently, the pins are easy to break, so you sort of gently push that in there. Okay, now that we've got our chip in there, let's take a little closer look. I'm going to use some of the pins here. So if we were going to, I know we had the diagram at the beginning, but it's kind of handy to have it here sometimes. So if we were to draw this chip again in the orientation that we have it right now, we're not going to use all the chips because we just want sort of one AND gate. But we want to be mindful of a couple things. Our first pin that we're going to use, this is pin 14, and this is where we're going to apply plus 5 volts DC. Now we've got a couple of other pins toward the end here. We have 8, 9, and 10, like that. And I wonder if this is going to be upside down in your video, so I'll reorient this. But this is where our AND gate sits. And 8 is the output for our AND gate. And then 9 and 10 are the two inputs. So 9 sort of goes like this, and 10 comes across and does this guy here. Now the other thing that we need is the ground pin. So we've got pin 7 over here, and that is our ground. And then if we're going to be really complete, we would say that our little dimple is right there. So again, that's sort of what we got going on here. Okay, so this is our circuit that we're going to build, or at least the gate that we're going to use in our circuit. Okay, so we need to get power to that particular components in the circuit. So the way that we're going to do this first is I am going to go ahead and use the sort of the column approach. And so we'll do it this way. We'll just put one on either side, and so when I apply voltage, they're separate from each other. Now the chip here, the LS series of chip, has an operating voltage of 4.75 to 5.25 volts, and I'm a little worried about my 9-volt battery. So what I am going to do is apply, or I'm going to stick a resistor in the circuit to drop this down. Do a little testing. This seems to do the trick. Drops it down close to 5 volts. So I'm going to do that. So now my new power takeoff is not right here. It's actually this column here. And so the way that I would get power over to my chip to pin 14 here would be to grab where the resistor is plugged in, and then plug it into the same column as pin 14. So you can see these are all in the same column. Now sometimes, especially with eyes as old as mine, sometimes you really have to look close whether or not you got those plugged in. All right. Well, the next thing we need is output from our AND gate. So pins 8, 9, and 10 are right here. So I'm going to go ahead and grab this output right here. You know, it's just the same column. I'm just trying to make it easier for the camera to see. So I'm going to spread them out a little bit. And I'm going to bring this guy just, over there. Now the next thing we need is an LED. Now I've got two LEDs here. We're just going to use this red one. But these two LEDs have, there's a difference between them. And one is a current limiting LED and one is not. So if I didn't have the chip here, which has some protection internally, or that resistor right there, I could really cause some problems for this LED because it doesn't have any protection of itself. This guy here is a current limiting and has a built-in resistor. The CanaKit, the ones that come with your Raspberries, do not, which is why a lot of the circuits that you see have a resistor in series with the LED. Okay. Now, other features about an LED is that one leg is shorter than the other. You can see that here. So the longer one is the anode. This is the cathode, or the negative side. But if you had it plugged in, how would you know? How would you know which side is which? So if I plug this in, hopefully I get this in here the right way. There we go. Note that I put them in two different columns. I don't know if you can see that. Two different columns because I want power to come over to here and then go through the LED, and then eventually we'll send it to ground. But how would you tell the negative side and the positive side, or the anode and the cathode? Well, the cathode side, the negative side, has a flat side to the LED. And I don't know if you can see that on the camera. Maybe if I do it like this. This side is flatter than that side there. And so that's how you tell when you're looking at one in a circuit. Now to complete the circuit, I need to bring the LED here. I need to bring this down. Now I'm just going to bring it sort of over here. We're going to do sort of a big loop here. Now I gave power to the chip, but I did not go to pin 7 and finish the connection. So what I'm going to do, I'm running out of short ones here. So I guess we'll just sort of bend this one out of the way a little bit. So we're going to do from that column to here. Get in there, there we go. And then we'll jumper these guys over like that. Now I could go, straight over here, but I'm trying not to make this too cluttered so we can still see what's going on. All right. So the way this would work is that when I hook up the battery, right, it goes through the resistor over here via this jumper to the chip, powers up the chip, and the chip has a complete circuit. If the output of our AND gate here is correct, then the LED should light up, and then that's its complete circuit. All right. Now, before we finish this off, here's a funny thing about these chips. The chips have voltage that's elevated on the pins, and so what we have to do is we have to drop the voltage on the pins and then apply voltage by removing the whatever we're using to drop it. So it might be a resistor that we put in there. We are just going to take our two inputs, our 9 and 10, right, this guy right here, and this one right here, and we are just simply going to run them to ground, or to the negative terminal of our battery. All right, so I'll actually show you what happens if we don't do that. So let's go ahead and power up our circuit, and we can see that the light comes on. The minute I touch the battery, right, the light comes on, and that's because power is asserted. So we need to drop the voltage that's applied here, and this is why on some circuits we take we take wires out to actually turn things on. I know it seems a little backwards, but that's the way that works. Okay, so now we plug our battery in, and life looks good. All right. Why does life look good? Well, and just in case, I'm not sure which direction the camera is going to be facing, so we'll turn it this way. So while we're waiting, right? What we're trying to do is a truth table, and so what we've got is inputs. Well, I'll draw it one way and then I'll turn around. We'll look at it both ways. So I have two inputs. I have input 9 and I have input 10. And the two inputs will be either a 0 or a 1. Now by that I mean that we either have voltage or we don't. And what we're going to do is the same thing for 10. And the question is, when we have these two inputs, what happens when we apply voltage or we turn on our inputs for our gates? All right. So with no voltage applied, right, what we get is a 0 on 9 and a 0 on 10. So these two inputs have no voltage applied. We're killing it off here. So the output for the AND gate is a 0. Now what happens if we lift one? So we could we'll lift the green one first, which is pin 10. So if we lift this one, the light stays off. Well, why is that? Well, because on an AND gate, if we have a 1 on one and a 0 on the other, well, we still get a 0. Okay, let's try to lift the other one. I think we lifted green, so let's lift yellow. Same thing happens, no LED. So in that case, we have a 1 on 9 and a 0 on 10. We get a 0 on the output. So the only time that we get a 1 on an AND gate is if we have a 1 on both of our inputs or a voltage on both of our inputs. And that would be that we lift both of our leads. There we go, and our light came on, indicating that we get output or a 1. Anytime I plug in any of the other ones, right? Oh, we got a little, oops, wrong one. There we go. If I plug in any one of these, right, and I kill off either one of them, then my light goes off because I've taken away the input. I must have both inputs to get the 1 on the output. So ding, 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 ding. There's our outputs. And if the camera's turned around, hopefully you can see that. All right, but the truth table, as you saw, the circuits and the truth tables are at the beginning of the video. Now, there is one other thing that I wanted to show you, and that is that we can use the Raspberry Pi, power portion of this guy here. And so, just for safety, I'm going to unplug my battery here. And what I'm going to do is use the outside channels instead. It makes life a little bit easier. It's also really great if I have a chip that's over here, right? Instead of trying to jump her down here, I can just jump her over to the side. So that's a really handy way to go about this. But if we were going to do this, what we would do is we would put the battery up here. Okay. Whoops. We can get it in there. There we go. And now I could take my resistor and bring it down here. Now, as long as I don't, it's a little crooked because it's a little long, and then I would just bring my power off the end of that resistor. Now, it's not really obvious what the benefit of there is because, again, we only have one chip. But over here, what we can see is that it brings the common or the negative terminal much closer. So if I bring, now I could use that one over there, I'm just going to use this guy here. So now this entire thing is the negative side of the battery. And what I would do is, again, jumper for, I got to power up the chip. Right. And, oops. Uh-oh. My connector broke. There we go. And
I'm going to send my LED over there. And now you can see that I didn't have to jumper anywhere, right? And now I can, drop the voltage on my two inputs just by plugging into the side here, like so. Oh, get in there. All right. So now when I apply voltage, I should be in the exact same condition that I was before, and it should work in the exact same way. I pull one, it doesn't work. I pull the other one, it doesn't work. Right? And then I pull the two of them. Oop, there we go. We got a loose wire. We got some. Stop. There we go. All right. Good. So that works exactly the same way. Now I'm using the power channels on the outside. I got a wiggly wire here, but there we go. But there you have it. Stand still. Stand still. Okay, good. Well, it works while I'm holding it. Well, that sometimes happens when you got a loose connection. Okay, so that is the basics of the 74LS08, the AND gate chip with 4 AND gates on it. We've got a couple of jumpers here. We know now how to work with a breadboard, how to get power in a couple of different scenarios, what we have to do to protect an LED, either by putting a resistor with the LED or dropping the voltage somewhere to bring it down within operating margins. The output of the Raspberry is actually already at 5 volts, so we protect the LEDs by putting a resistor over here because we don't have this chip in the circuit helping us out either. And that will about do it for our AND gate and our truth table for the AND gate.
Now my friend, colleague, and local technomage, Larry Hill, wanted me to remind you about something, and that is Ohm's law. Okay, so Ohm's law is a fundamental electrical property that says voltage is equal to current times the resistance through the circuit. But here's one of the gotchas, that the loads in the circuit often don't drop voltage until the current is flowing through them. Okay, so why do we care? Well, the reason, if you were paying attention in the video, the reason that I put this resistor here is because I was nervous, right? This is a 9-volt battery. We've got 5 volts here. That's the operating range of the, actually 4.75 to 5.25 volts is the operating range of this chip. And so I said, well, we'll put a resistor right here, which is fine for what we're doing here. So once current starts to flow, then voltage gets dropped across the resistor and the supply voltage is lower than the 9 volts. All right. Now when current is not flowing, meaning that we're not doing anything with the gate, this 9 volts appears everywhere because there's no current flowing. So the potential exists everywhere in that circuit. So the top one is the one that we built for this little demonstration. Now if we were going to build a bigger battery circuit, we might want to move the resistor over here. So we just removed it from here and we put it over here. Well, why would you do that? Well, if I drop enough voltages, it's possible that I end up having, once current starts to flow, a voltage that is below the operating value of the circuit. By moving the resistor, I actually make this resistor specific to whatever is going on in this LED. Not only does it protect an LED that has not got a current limiting resistor in it, it also makes it specific to this. So I could add other parts to the circuit with their own resistors, and so only if something's happening in that part of the circuit do we drop the voltage. And so in this way, whatever the voltage is on this side is the voltage that's applied to the chip. Just a little advanced know-how for how Ohm's law works in a circuit like this. Well, there we go. There were some circuit basics. I hope you enjoyed the build. We were talking about breadboards, LEDs, resistors, and of course our chip, which was a 74LS08 with 4 AND gates. And we showed how the truth table works and the operation of a single AND gate. Thanks for watching. Thanks for listening. Like and subscribe if I help. And may those, well, we'll call them 1s and 0s, reach their destinations no matter what kind of logic gate you're going through.